Hi everyone, my name is Subham, your instructor for this brand new NumPy course. In this course, we are going to cover each concept of NumPy in a very detailed way from basic to advanced NumPy. So NumPy is very important if you want to excel your career in data analytics, right? So let's start this session with some of the questions which help you to understand why you should learn NumPy. The first question is, what is NumPy? Second question, why you use NumPy? Third, why we are using NumPy array over the list? Because in a Python, list is there, so we can use list as well, but what are the limitations of the list, what are the disadvantages of the list, so that we use NumPy array over the list. Okay, at last we are going to see the application of the NumPy. So first we are going to see what is NumPy. So NumPy is a library which is used to scientific computing in Python programming language. It is an Python library which provide multi-dimensional array object and various derived object, matrices and masked array. So NumPy is just a library which help in scientific computing, right? And it also provide a multi-dimensional array, means with the help of NumPy you can create more than one dimension array, maybe 2 dimension, maybe 3 dimension, maybe more than that, right? So at the core of the NumPy is the ND array object. This encapsulate n dimensional array of homogeneous data type. What is homogeneous data type? Homogeneous means each element of that array have the same data type, means the NumPy array contain all the element with the same data type. Okay, next is NumPy array are homogeneous set of element. I've already explained this line.
I like wide shooting. I'm a great believer in what Charlie Chaplin said, is that a life is a tragedy in close-up and a comedy in long shot. If you sit back visually on a situation, it automatically becomes funnier. I mentioned, which is a French comedian called Jacques Tati, who said that comedy begins in the legs. And making a character more real and more sympathetic and more identifiable doesn't necessarily make him funny, because in many ways what's funny about Mr. Bean, for example, is his complete sort of selfishness, and he's a natural born anarchist. So he's a child trapped in a man's body.
Why we are using NumPy array over the list? There are so many points here I have written here, and you will see what are the differences and for what reason we are using NumPy array over the Python list. Okay, so this is the NumPy array. The first point is, if you take the first point, here all item are integers, means in this example I have chosen all the item in this array are integers. Here we can store item of one data type. It means what? Means this array contain a homogeneous data type, means each element has the same data type, so it is faster to read byte from the memory, because if the data type is same, you need to go at one place to access all the element or to read each byte of the memory. But in the Python list, when you see, Python list contain a mix of integer, float, string and list itself. So it is an heterogeneous element. So here we can store item more than one data type, means here you can see the first is integer, then it is string, then it is float, and then it is list itself. Now if you see the next point, that is very important, no need of type checking. It is very simple, because each item has the same data type. Here you can see each item has the same data type. In this scenario we have taken all item are integers. So if we have a same data type, so we don't need to do type checking, right? So it make it faster. But in the case of Python list, when you see each element has a different data type, So you need to check each element. So it take an extra time for this type checking. So this is the benefit in the NumPy array. So it make it faster. There are so many reasons, but this is one of the reason which make NumPy array faster, right? The next point is it store data in a continuous memory. With this, it make faster access the data. I hope you know why continuous memory access the data faster, because if the data is in a continuous way, then in that situation you can access the data in one go. But in the Python list, when you see, it do not store the data in a continuous memory. Due to this, it take much time to access the data. When the data is not stored in a continuous memory, you need a pointer to access the data. Basically, pointer store the address of the item, right, inside the memory. The next we are going to see, that is very important, NumPy array facilitate advanced mathematical and other type of operation on a large number of data, because in the real life scenario, when you will going to deal with the real world data, there are millions and billions of the data. So in that situation, NumPy array helps us, but in the case of Python list, this is not the case. So these are some of the factors which clearly identify that NumPy array is more faster than a Python list. So that we can use NumPy array, it is faster, as well as we have advanced mathematical function that help a different type of operation on a large number of data set. So this is the brief introduction of why we are going to use the NumPy array over the Python list. Okay. Application of NumPy, I have already speak about these points. Okay, you can see using NumPy we can create multi-dimensional array. I have already explained you can create a single dimensional array, or you can create a two-dimensional array, or you can create a three-dimensional array, right, like this. So the next point is has the great use in the machine learning, because if your NumPy is strong, if you have a proper understanding of the NumPy, that really help in the machine learning. Okay, and replacement of MATLAB. So MATLAB is a programming platform designed especially for the engineer and scientists to analyze, design system and product that transform our world. It basically a tool which is used in the mathematical approach, all the functions related to the mathematics. If you see here, is MATLAB has a very strong mathematical calculation ability. Python is difficult to do. So with the help of NumPy, we can upgrade the functionality of the Python so that it works for the machine learning as well. So these are the points, and the last way I've already explained you, it has a advanced mathematical function which make the machine learning algorithm easy to use. So these are the things that you need to understand. I have already explained you what is NumPy, why we are going to use NumPy array over the list, and the third is application of NumPy. From the next lecture, we are going to jump into the section and we start from the basic of NumPy, learning from the basic how we can create the NumPy array, what are the attributes, what are the method, what are the mathematical function, how it works. We are going to see each and everything from the basic to advanced NumPy. Okay, thank you.
Diplomacy is an art of detail in a way. Okay, there's a lot of nuance, body language, how you dress, what you say, how you look, how you hold your hands or don't hold your hands. So all of this counts. It depends on the person, it depends on the situation. It's a bit like a choreography. So you use that occasion to do the signal. That's why it would depend on the situation. So there are times and occasions. So I wouldn't say there's a single formula.
Now in this session we are going to create a first NumPy array. For that we need to first import NumPy. For that you know to import NumPy. Import NumPy as NP. You run the ceil, you will import that NumPy. Let's suppose if you want to create a one-dimensional NumPy array, then you need to do a is equal to a simple thing np.array, and in that array you need to pass a list. When you run this ceil, you will get an array. If you want to check the type of this array, you will see it is NumPy ND array. Okay. Next we are going to see how you can create a two-dimensional array, right? So for two-dimensional array you need to do simply np.array, and in that you need to pass a two-dimensional array, right? When you print, you will see it is a two-dimensional array. You will observe here this is a, when you see it is something like a vector. So 1D array it is also called as vector. A 2D array it is also called as matrices, because if you see this it looks something like matrices. Let's suppose now I want to create a three-dimensional array. Okay, so np.array, I need to pass here a three-dimensional array 1, 2, 3, 4. Pack this. Now here 5, 6, and here 7, 8. When you run, you will see C is something like this. It is a three-dimensional array where there is a two-dimensional array. This is the first two-dimensional array in which the item is 1, 2, 3, 4, and this is the second two-dimensional array in which the item is 5, 6, 7, 8. Okay, so a three-dimensional array it is also known as tensor. You will observe here by default a array generated with the integer data type. Here you can see 1, 2, 3 all are integer. Here as well 1, 2, 3, 4, 5, 6 all are integer, and here as well. But let's suppose if I want to create an array with different data type, np.array, and if you want to pass here a list 1, 2, 3, by default it is integer, but when you specify here float, then you will get a array in which the all element is float data type. You will see here each element is float data type. You can do anything. You will do bool. I think bool is something like this. Okay, you will see here true, true, true. Why all the value are true? Because in Python you will see a non-zero value is always true. If you put here 0, you will see a false, right? So I hope you understand D type, the importance of the D type. It creates a NumPy array with different data type, right? The next we are going to see a range function. It is similar to the range in the Python programming language with the same syntax. Okay, like np.range, and if you pass here a range is starting from 1 to 8. So it print 1, 2, 3, 4, 5, 6, 7. It eliminate the last element. I hope you know. Okay. So this is also a way you can create a NumPy array. Let's suppose if you want to print the alternative number, like 1, after that 3, after that 5, after that 7, then how you print? So in arange there is a concept of step 1, 8, and here you need to put here 2. It means it take one step, take the alternative value, right? It print 1, eliminate 2, print 3, eliminate 4, print 5, eliminate 6, print 7. Let's suppose if I put here 3, then it print 1, eliminate 2 element, 2 and 3, it print 4, then eliminate 5 and 6, print 7. So this another approach to create a alternative number from an array, right? We are going to see reshape. What reshape does? It reshape the existing array in different shape. Let's suppose if I have an array of 1 to 9, that's it. It looks something like this. But if I want to reshape it, it contains 8 elements, 0, 1, 2, 3, 4, 5, 6, 7, 8. It means we can reshape into 2, 4. Now it is 2 rows and 4 column, 2 rows and 4 column. You can also reshape into 4, 2, where 4 rows and 2 column. But you can't reshape into 3, 2. It's an error. What? Cannot reshape array of size 8 into shape 3 into 2, because 3 into 2 is equal to 6, but in our array it is 8 element. So this is not possible to reshape. So you can only reshape by the multiple of that number, right? Okay, I hope you understand how reshape work. Okay, let me give you another example. The 3D array that we have worked, C. Let's suppose I copy from here and we print here this. It print this array. Let's suppose if I want to convert this 3-dimensional array into something else, like reshape. It contains 8 elements, so you can reshape into either 2 into 4 or 4 into 2 or 1 into 8 or 8 into 1. Let's suppose we try to convert into 4 into 2. So it looks something like this, right? So you can reshape any array in different form, right? Okay, it's nice. Okay, now the next is we are going to see the zeros. I hope you know what is the concept of zeros. It create a NumPy array with all value is zeros. So NP zeros create NumPy array with all value is zeros. Let's suppose if I want to create NP zeros, and here you pass safe 2, 3. Oh sorry, you need to pass here like this. You need to pay. It means it form a 2, 3 matrices where each element is a 0, right? So I hope you understand how you can create all the value zeros. You need to put here the safe. You simply do 4, 2. It create an array of 4 rows and 2 columns where each element is zeros. Similarly for the ones as well. You simply do dot ones and here you pass 3, 2 or something else. Let's suppose next is random. What is the importance of random? It create a NumPy array with random value. Okay, so the syntax is random dot random, and you need to pass here the shape. So it create a random value between 0 and 1, right? You can choose any, save, you will get the result. Okay.
Humans do some really interesting things. Like, besides killing ourselves, we also kill each other. Murder. And we're the only ones who do that, by the way. We're the only species on Earth that deliberately kills members of our own species for personal gain. Or pleasure, sometimes it's just fun. We're also the only species that deliberately kills members of another species for personal gain. Or pleasure, that's what hunters do. They kill for pleasure. That's us. Human beings, interesting folks. Murderers.
Now the next is linspaces. What is linspaces? Linspaces is very important. I think you need to understand very carefully. So linspaces create a NumPy array with linearly spaced value, right? So what does linspaces means? I will show you right now. Linspace, and you have to pass here, let's suppose -10 to 10, and you want 5 different value between them. So what it create? It means from -10 to 10, it try to create a 5 equal value. When you subtract each value, the alternative one, the result will be same. Like -5 minus -10 is equal to 5. 0 minus 5 is equal to 5. So the result, it means the distance from one point to the other point is equal, right? I hope you understand what is the concept of linspace. It try to create a linearly spaced value from this starting value to the ending value and how much value you want between them. I want 5, so it create 1, 2, 3, 4, 5, and each value is linearly spaced with each other. The next is identity matrix. So you need to do identity, and you need to pass here the size of identity matrix. You will get here identity matrix in which all the value is 0 except the principal diagonal element, this element, this year 1, year 1, year 1. So in the next session we are going to see all the array attributes and different method and functions, right? Thank you. Okay, now in this session we are going to see the array attributes. There are so many attributes like name, shape, size, item size, datatype. So we are going to see all of this. For that I want to create an array. Let's suppose this A1. Let's suppose I want to create a 2-dimensional array as well, and we dot arange, and we pass here, let's suppose 12, and we want to change the data type of this to float. Okay, and we want to reshape into 3, 4. So this is a 2-dimensional array, now creating a 3-dimensional array, and we dot arange, and to pass here 8, and want to reshape into 2, 2, 2, right? When you run this ceil, you will get a 1-dimensional array looks something like this. A 2-dimensional array looks something like this because we have given here explicitly the data type is float. That's why all the value are in the float, and it is reshaped this array into 3, 4, 3 rows and 4 column, the 3 rows and 4 column. Next is A3. When you see, it is an 3D array where there are two-dimensional array, right? Here 1, 2. Okay, let's suppose if I want to know the dimension of any array. So ndim is an attribute which help you to give the dimension of an array. Let's suppose if I want to know the dimension of A3 ndim, you will get 3, it means it is 3-dimensional array. Similarly, if you put here A2, you will get it is a 2-dimensional array, right? So endim is for giving you the information about the dimension.
I almost bailed on being a filmmaker. And the thing that kept me in the game was the possibility of the Avatar universe reaching a lot of people with a persistent kind of emotional message and reaction on the part of the audience to maybe fight for and protect that which we're losing. So that was the point at which I decided to go ahead and make more Avatar films, which was actually a difficult decision because I had a lot of things I was interested in terms of ocean conservation and sustainable agriculture, a lot of projects I was working on that I had to turn away from to go back into the saddle as a filmmaker.
The next is safe. Let's suppose A1 dot safe. You will give, it contain 8 rows, so it simply do 8 comma. If you put here 2, then it give you the safe that 3 comma 4. It means it has 3 rows and 4 column. We have already seen this. When you print here, it is 3 row and 4 column, right? And when you print here A3, it is like, when you see the shape of A3, it looks 2 comma 2 comma 2. Means there are 2 matrices in which both have 2 rows and 2 column, right? 2 rows and 2 column. I hope you understand. To shape, it give the shape of an array, or you can say it gives the number of rows and columns in that particular array. The next is size. So let's suppose if I want to know the size of A1, so it is 8. So what size signifies? So it gives the number of item in the array. So it gives the number of item, means the length, you can say, like A2 dot size, when you give it is 12, because when you print A2 here, you can check here, print A2, it contain 4 into 3, it is 12 element. Okay, so size will give you the number of item. Let's suppose A3 dot size, you will get 8. Okay, you can check here as well. A3, it is 8 element, 0 1 2 3 4 5 6 7, right? The next is item size. It is very important. Item size, it give you the information of how much space it is received inside the memory. So item size give you the information of how much space it is received inside the memory. Let's suppose A1 dot item size, when you do, it is 8 byte, right? Let's suppose A2, it also contain 8 byte, and A3, it also contain 8 byte. Due to some reason, Jupyter Notebook not able to find the correct item size, but if you are going to do the same thing on different platform like the PyCharm, you will get a different result. But if you see here, the result will be the same, but you can check here with this. Try to convert the, let's suppose A1 is equal to np dot arange, to pass here 8, and you need to explicitly pass here dtype is equal to np dot int 32. So by default, every integer in this Jupyter Notebook taken integers 64, but if you explicitly put here integer 32, then you try to check here the A1 dot item size, you will get 4. I hope you understand. By default in Jupyter notebook, I don't know why it is happening, but it take everyone's as integer 64, but when you explicitly put here the data type is equal to np.int32, you will get a different size. Let's suppose I want to ask you a question, how many bytes we need to store the A1, because each item size is 4 byte and A1 contain 8 item, so it means it is something around 32. I hope you understand, but okay, give me time. Question, how many byte it take to store the A1 array inside the memory. So you need to do A1 dot item size and you need to multiply with A1 dot size. Why I am doing this? Because item size give you the number of byte it take to store one item, and A1 dot size give how many item it has. So one item take 4 byte and it contain 8 items, so the result is 32 byte. I hope you understand. Item size will give you the number of byte it take to store one item, and if I multiply the number of item, it will give the total number of byte it take to store A1 array inside the memory, right?
You know, sometimes even I say Bollywood, but I keep going. I was like, no, say Hindi cinema. Hum kisi se kam nahi.
So the next is dtype. It gives the information of data type of an array. Let's suppose A1 dot dtype. If I want to know A1 dot dtype, it is integer 32, because here you can see we convert the A1 data type from integer 64 to 32, but when you see the A2 data type, you will say it is float 64, because if you see here it is float 64. So by default every data type in the Jupyter notebook it take the 64 byte, right? So if you check the A3, it is integer 64. Okay, let's suppose if I want to change the data type, if I want to change the data type of any array, then how you can change? Let's suppose A3, and we're going to change the data type with the help of S type. If you put S type inside this np.int32, right now here we can see that the data type of A3 is integer 64, but if I want to convert this A3 integer 64 to integer 32, then what will happen? You will see here it is converted to integer 32. So these are some of the ways you can convert the data type of any array, and these are the some of the attributes we have seen: and name, safe, size, item size, data type, and we also see how to change the data type, right? Thank you. In the next lecture we are going to see all the arrays operation. Okay, thank you. Now in this session we are going to see the array operation, in which we are going to see the scalar operation, relational operation, and the vector operation. For that I need to create one array. Let's suppose I create np.arange function with the help of arange function, and we want to reshape this into 3, 4. Okay, let's suppose create one more array, because in the vector operation you need 2 array, so that I can show you how these things work. Arrange, and for that let's suppose 12 to 24, and you need to reshape this into same 3, 4. Okay, we want to see, you can see A1 is look something like this from 0 to 12, 11 because it is arrange 12 and reshape into 3, 4. It means 3 rows and 4 columns. If you want to see A2, it is same, but the value is from 12 to 23, right? Let's suppose what is scalar operation. So in scalar operation, you simply do the, let's suppose a vector is given. If I want to multiply each element of that A1 by 2, then what it result? If you see A1, it's like 0, 1, 2, 3, and when you multiply each value with 2, it is 0, 2, 4, 6, 4, 8, 10, 12, 14. I hope you understand. If you want to do anything, if you want to add 2 in each value, it looks something like this. If you want to subtract 2 value, like this. If you want to modulo 2 value, it looks it will division, and if you want to modulo it like this. Okay,
I was different. I still am different. I'm in a country which is very far away from home, very far away from familiarity. And I think that's what my strengths are. When I was young, I didn't understand that. When I was a kid in school, when I was being bullied, when I didn't understand who I was turning into. But what makes you different if you identify that and you realize that, all right, this is what's different about me. If you think about it, that's exactly what makes you special. That's exactly what makes you unique. And you need to just, and I did that over time, be the best version of yourself. Because the more different you are, the more special you are.
The next is relational operation. What does relational operation means? The relational operation consists of less than, greater than, equal to, not equal to, this kind of operations. Let's suppose if A1 is given, and if I put here A1 greater than 1, it gives a result that is false, false, true, 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 true. Means it gives the Boolean result. Means for every element it check this condition, and if it is correct, it return true, and if it is not correct, it return false. In this case, if you see A1 here, the first value is 0 and 1. First value is 0, and after that it is 1. So 0 is greater than 1, false. 1 is greater than 1, false. After that 2, 3, 4, 5, 6, all these value are greater than 1, then that's why all value are true, right? For the 0 and 1, it give the false result because 0 is not greater than 1 and 1 is not greater than 1. So you can use here anything, like let's suppose 1, 0, 10. So only this value is true because it is 11, right? You can also do equal to. It means everyone false because none of the value of A1 is equal to 1, 0. Let's suppose 0. Only 1 is true. Let's suppose not equal to 0. This is the symbol of not equal to 0. Okay. Then you will see the first one is false because it is equal to 0. A1 first value is here equal to 0, but in this condition it is given not equal to 0. That's why it gives a false and the rest is true, right? So I hope you understand. You can use any relational operator here for this. The next is vector operation, and in the vector operation you will do an operation between two vectors. That's the only reason I have chosen here the two vector A1 and A2. Let's suppose 1 and I want to add A2. It means what it do? It simply A1 plus A2 means each element of A1 is added with the each element of A2. For your reference, I try to print here both the value. A1, it is this, and after that A2, it looks something like this. Then it try to add A2 and A1 on a item basis. 0 plus 12 is equal to 12, 1 plus 13 is equal to 14, 2 plus 14 is equal to 16, 3 plus 15 is equal to 18. So on a position basis, it try to add. You can same do your any operator you can use, like let's suppose multiply. So it is very big number, and if you learn modulo, you can do anything. So you can use any operator. So these are the things that you can keep in mind. So there are scalar operation. After that we know about the relational operation, and after that the vector operations. Okay, thank you. In the next lecture we are going to see the array function. There are so many functions in the array, like the max, mean, median.
Well, I'm actually incredibly excited about the future of India. I think India has more promise than any large country in the world. I am a fan of Modi, so I like him quite a lot. It was a fantastic meeting with the Prime Minister. He really cares about India. He's pushing us to make significant investments in India.
Now in this session we are going to see the array function. There are so many functions in the array, but we are choose the specific one that we are going to use on a regular basis as a data analytics or a data scientist, right? So the first is max, mean, or the sum of product. After that we are going to see the mean, median, standard deviation and variation. After that log and exponent. After that we try to know the concept of round, floor and ceil. So let's start by creating one array with a random value, let's suppose, and we want a size 3 into 3. So it, oh I think sorry, there is a misspelled here. Okay, 3 into 3, it's working. So it create an array with the value between 0 and 1. If I want to make it np dot round function, I will explain you this round function, but right now I use this so that I can get the value between 0 to 100, right? So that I can get the value between 0 to 100. Okay, now this is the array. Let's suppose if I want to find the maximum element, maximum, so we simply do np dot max and we part and we push the name of the array. So 84 is the maximum element. Here it is 84, right? Let's suppose the mean, you can use mean as well, that is 3. Here is it. But I want to know on a column basis or a row basis. Let's suppose if I pass here axis is equal to 0. What does it mean? It means in every column which value is the minimum I get. So in the first column 21 is the minimum, in the second column 3 is the minimum, in the third column 79 is the minimum. So here 21, here in the second column 3 is the minimum, and here in the third column 79 is the minimum. So if you do the same thing with the row, if you want to find the minimum element in each row, you need to put here x is equal to 1. So in first row 3 is the minimum element, in the second row 11 is the minimum element, in the third row 4 is the minimum element. So I hope you understand what is the concept of minimum and maximum. Let's suppose if I put here sum and we eliminate this, what does it give? It gives the sum of the entire array, right? It gives the sum of entire array. Likewise, product, it will the multiplication of the every element of this array, right? So it is so big. Let's suppose if I want to sum each row, then you have to put here axis is equal to, what is row? Row is equal to x is equal to 1. I have written here so that you can remember this. So x is equal to 1, it means on a row basis it perform the sum on A1. So on A1, this is the first row. When you sum it, it is 128, right? This is the second row. When you sum all the three value, you will get 120, right? And this is the third row. Where you sum the element, you will get 104, right? So these are the ways. The same thing you can do with the column as well, by this column, this 41, 27 and 21. When you add this, you will get 89. Likewise others. Okay.
And then just work like hell. I mean, you just have to put in, 80 to 100 hour weeks every week. And then
a lot of work.
All those things improve the odds of success.
Okay.
I mean, if other people are putting in 40-hour work weeks and you're putting in 100-hour work weeks, then even if you're doing the same thing, you know that in 1 year you will achieve what they achieve. You will achieve in 4 months what it takes them a year to achieve.
Okay. I like your work ethic.
All right.
Thanks. Elon.
So you can do these things like if you want to find the mean of the entire array. Okay, sorry. You need to pass here the value on which you want to find a mean, A1. So the mean of the entire array is this. But you can do the same thing here as well. You need to pass here axis is equal to 0. It means it gives the mean of each column. So each column, you will, in this column the mean is 29.6666. This column you will find mean, it is 11 plus 3 14 plus 14 18, and 18 divided by 3, that is 6. I hope you got it, right? So you can use any function, the median. If you use here median, like MA median. So median try to give you the middle element. Okay, the median is like you need to arrange this number in an ascending order and then find the middle element. When you arrange this 41, 27 and 21 in ascending or in descending order, the middle element is 27. When you arrange this 3, 4 and 11 in ascending or descending order, the middle element is 4, right? When you arrange this 79, 82, 84 in ascending or descending order, the middle element is 82. So I hope you understand how you can find median. So first, I write here, first you arrange the value in ascending or descending order, then check the middle element. Okay, like suppose if you give here 1, it means in every rows it try to find the median. Let's suppose this is the first row. When you arrange this in ascending order, it's like 3, then 41, then 84. It means the middle element is 41. That's why here it is 41. When you arrange this row, the second row into ascending or descending order, you will get 11, 27 and 82. In that, the 27 is the middle element, right? I hope you got it.
I would make it a rule for everyone to understand that it's okay to love yourself. I feel like people think that maybe they're conceited or it's wrong to think of yourself first sometimes. I think that's a great thing. You should be your biggest fan, you know? You should look in a mirror and be like, dang, girl, you look good. You should like pump you up the most.
The next is dot product, right? Then how you can find a dot product. So dot product, let's suppose if I create one array, let's suppose A2 and p dot arange and to pass here 12 and reshape this into 3 comma 4 and A3, let's suppose np dot arange and 12 to 24 and reshape into same 3 comma 4 comma 3. Why? I will explain you why. Let's suppose if I print here A2, it is this, and when I print A3, it looks like this. In this, there is 3 comma 4 means 3 rows and 4 column, and A3 is 4 rows and 3 column. I will explain you how this product happen with this example. Let's suppose here the first matrix M1 is this and the second matrix M2 is this, or you can call them array. Shape is 2 comma 3, it means 2 rows and 3 column. His shape is 3 comma 2, 3 rows and 2 column. You can only do the product when this value matches with this value. Means the number of column in M1 is equal to number of rows in M2. I repeat once again, the number of column in M1 is equal to number of rows in M2 must be equal, then only you can do this dot product. Result will be this 2 into 2. This here it is 2 into 2. Then how this product happen, I will explain you. First you need to take this row of M1 and this column of M2, and you need to do the multiplication with each element and add them. Like here you can see 0 is multiplied with 6, 1 is multiplied with 8, 2 is multiplied with 10, 0 is multiplied 6, add, and we add all the value. Again this same rows with this column now. 0 is multiplied by 7, 1 is multiplied by 9 and 2 is multiplied by 11, and add all of them, you will get 31. Likewise now this row and again the same column, this column and this column. When you do this, you will get a result 28, 31, 100 and 112, right? I hope you understand how dot product work, right? So when you see this inside here, when you solve this question here 2 comma 3, I try to change this value so that you can relate this with the example I have given you. 212 and it is 3 comma 2. When you do the dot product np dot dot and you need to pass here a2 comma a3, you will get the result here 28, 31, 100 and 112. You will match from here 28, 31, 100 and 112, right? I hope you got it right. The next we are going to see the log and exponent. You know how logs can be found, but with the help of NumPy we can find it very easy. NumPy.log, and if I pass the a1, then it try to find the log of each element in the a1, right? I have already seen here is the a1, right? And it find the log of element of a1. So these things can work. Similarly, the exponent.
Following your dreams is never easy, really, because, you know, it's going to take work, and it's going to take dedication, and it's going to take focus, and it's going to take drive. But as long as you really love it, and you really want it, and you keep that laser focus, then nothing is impossible. You got this.
Now, the next we are going to see the round, floor and ceil. I have added a small note here. You can read it so that you can understand what I am explaining you. The first is round. It take the nearest integer. What does it mean? It take the nearest integer. Let's suppose if I want to round the value of 3.1, it give 3, means 3.1 is nearest to the 3. But if I put here 3.8, then it is nearest to 4, because let's suppose I will explain you this with the help of this example. This is the number line. Let's suppose 0, 1, 2, 3, 4. Let's suppose if my value is 3.1, here it is 3.1. 3 is more nearer than 4, so it take the value is 3. But if I take 3.8, means it is more nearer to 4 than 3, so it value is 4. So it simply do like if there is a 3 and there is a 4 or any value, 3.1, 3.2, like 3.7, 3.8, 3.9, all these value are nearer to 4, so all this 3.6 to 3.9 equal to 4, but 3.1 to 3.4 equal to 3, right? So it basically find the nearer. Let me give you an example. Let's suppose if I put 3.5, then it is 4. So from 3.5 to 3.9 it shows 4, and of course the 4 is 4. If you put here 4, you will get 4, right? This is the round. But if I want to know what is floor, it take the left part of the given integer on the number line. Left part. Let's suppose if I do floor 4.2, then np.floor. Sorry, my bad. So it is given 4. If I put 4.8, it also given 4, because here you can read it take the left part of the given integer on the number line. When you print 4.8 on the number line, let's suppose you are printing 4.8, here it is 4, here it is 5, 4.8 is somewhat here. So I told you that it take the left part of the given integer on the line, means left part is what? Left part is what? It is the left part, it is the right part. So it always take the left part. Floor always take left, right? And if you see the ceil, it take the right part of the given integer on the number line. It means if I pass here ceil 4.8, it give 5 because 4.8 and the right value is 5 and the left value is 4. So I hope you understand what I am trying to explain you. If it is ceil, let's suppose np dot ceil, and we pass the same value 4.8, then it take 5 because I have already explained you, it take the right part of the given integer on the number line, and float it take the left part of the integer on the number line. Okay, and round it take the nearest integer. Round means round, if you pass 4.8, it take 5 because it is more nearer to 5 than 4. But if I pass here around 4.3, so it is more nearer to 4, right? It is not more nearer to 5, it is more nearer to 4. So I hope you understand the concept of round, float and ceil, right? Next we are going to see the most important thing, that is indexing and slicing. Indexing and slicing is one of the most important part of the NumPy. So in the next session we are going to see the indexing and the slicing. Thank you.
Like in the field of medicine, where robotic surgeries are like becoming more and more common and more talked about, even in the field of creation, there is a lot of talk about getting your images from artificial intelligence. AI has been making inroads quite rapidly, and the results are like mind-bogglingly good, amazing, scary. But so far, no one is able to create any tools where they can have a control over that imagery. Many people across the globe are spending, like investing, I don't know, like billions of dollars into making tools that can control artificial intelligence. If they are successful, the way we make films is going to change dramatically. But whether a person is needed or not is a very big question.
Now in this session we are going to see the indexing and the slicing. For your preference, I have already create 3 array. The first array A1 is a one-dimensional array, the second array A2 is 2-dimensional array, and the third array A3 is 3-dimensional array. Indexing works same way as in the Python language. If you have a basic understanding of Python programming language, you will know how indexing work for 1D array. So in this example, in this picture, you will see the value is 1, 2, 3, 4, 5. The positive index start from left to right, 0, 1, 2, 3, 4, and the negative index start from right to left, that is -1, -2, -3, -4, -5. So positive index start from 0 from left to right, I have already written here, and the negative indexing start from -1 from right to left. We have a concept of indexing as well as the slicing. What is the difference between indexing and slicing? So we fetch one item from the array with the help of indexing. With the help of indexing, you can fetch a single item from an array. But if you want to fetch more item at once, we are going to use the slicing. So slicing is very important concept to get more than one item from the array. So A1 look like this. This is A1. Again, if you see A2 is a 2-dimensional array, okay, and A3 is a 3-dimensional array, right? You will see A1, A2, A3, right? Let's suppose if I want to ask you a simple question. From the A1 you can easily find anything because I know you are smart enough. A1, if I want to find the second element. So you need to put here index 1 and you will get the second element, that is 1, right? If you want to get the last element, you need to do -1, you will get the last element, because I have already explained you the negative indexing works from the last of the array and it is started from -1, right? So 1D array is easy. Okay, so we are going to work on a 2-dimensional array and a 3-dimensional array. Let's suppose here is the 2-dimensional array. If I want to fetch this 11, how can you fetch this from a 2-dimensional array? If you put here a2 is equal to, first you need to check in which row this 11 is in the second row. Is the first one is the 0th row, the second is the first row, and this row is the second row. So it means there is second row, comma, which column? 0th column, first column, second column, third column. So third column. When you put here 2, 3, it is 11. So I hope you understand how you can find the value from a 2-dimensional array. First you need to specify here in which row and after that in which column, right? Let's suppose in 3-dimensional array, I want to ask you one question. In a 3-dimensional array, if you want to fetch this element, this value 2, how can you fetch? First you need to specify in this 3-dimensional array there are two-dimensional array. It is the first 2-dimensional array and this is the second 2-dimensional array. So in 3-dimensional array you first need to specify the value you want to find in which 2D array, because if you give here like 0, you will get the first 2-dimensional array, and when you put here 1, you will get the second 2-dimensional array. This is, it means first you need to identify the value 2 is in the first 2-dimensional array. So you put here, okay. Now after this you need to identify which rows and column, okay, which rows. It means is in the first row and 0th column, right? You will get 2. So in the 2-dimensional array you need to specify the rows and column. In the 3-dimensional array you need to first specify the index of the first 2-dimensional array. Means if I want to fetch 5, this value 5, then you know this 5 is not in the first 2-dimensional array, this 5 is in the second 2-dimensional array, means this. So you can fetch this array with the help of index 1, because first 2-dimensional array is index 0 and the second 2-dimensional array is index 1. Okay, now in this array you are going to fetch 5. It means which rows and which column. It means 0th rows and first column. You will get 5. I hope you understand what I am explaining you, right? Now I want to ask you one question.
Knowledge. But if it's one word's very hard for that, but the word is knowledge. But you get knowledge through experience. One of the things people talk about is luck. And I do believe that people are lucky and some people are luckier than others. I do believe that. But there's also an expression, the harder you work, the luckier you get. And I can tell you 10 instances where I didn't quit when it was 1990, the world was coming down, the debt markets were to everybody, all of my friends and enemies were going bankrupt, I never did. And the times were actually just terrible. And even today you look at times and you see what happens and you have to learn. But the word luck is very interesting, but if I didn't work really hard, I probably would not, almost definitely would not be here today. And unless you had me up as a man who at one point was successful, but let's see what a loser looks like. So you have to work hard, because it is true, you can develop luck through hard work.
From the A2, fetch the second row from the A2. If you see A2 is here, A2 is here. I want to fetch this row 4, 5, 6, 7. Let's suppose if you put here 0, you will get the first row. If you put here 1, you will get the second row. So in the two-dimensional array, when you fetch like 0, 1, 2, it gives rows. At the 0 index, it gives the first row. At the first index, it gives the second row, respectively, right? Let's suppose if I want to fetch the third column from the A2, means this 3, 7, 11, third column. Then what you need to do? So you need to ask here first which rows and which column. Third column means every rows. For every rows you need to do colon, comma, and which column? 0, 1, 2, 0, 1, 2, 3. So 3. You will get 3, 7, 11. Here you can do nothing as well. You can put this as well. The result is going to be same. What does it mean? It means first row and all the column. This column signifies all the column. Here this column signifies all the rows, because we are putting column in the place of rows, and here we are putting column in the place of column, right? Let's suppose if I want to ask you one question. Can you fetch 5, 6, 9, 10? This value 5, 6, 9, 10 from A2. From A2 you need to fetch 5, 6, 9 and 10. How can you find? First you need to identify which row. So rows start from 1. So you need to put here 1 colon. It means from 1 to every rows. It means this part. Because when you run this, you will get this part. Okay. Now in this part, you need to get 5, 6, 9, 10. When you run, you will get 5, 6, 9, 10. I think you understand how these things works. First, I want to fetch which rows, means from first rows to the last. So I put here 1 colon. Then here which column? I put from first column to third. It means it is skip the last column, right? And it print 1 and 2. That 5, 6, 9 and 10. Now suppose if I want to fetch 1, 3, 9, 11. Where is 1, 3, 9 and 11? How can you fetch? Let's suppose 1, 3 and 9 and 11. Take some time, try to fetch that 1, 3, 9, 11, right? So you can do like you need to first specify from where you are going to fetch. 1, it means which rows, from the 0th rows, 0th. 2, which rows, 9, 11, all the rows. Okay, but you are not going to fetch the second rows. So you need to skip. So it means you need to write the third row and skip. I have already explained you the step. Means whenever you put here 2, it means it print the alternative row. If you don't believe on me, you can see. I put here from start from 0 indexing, 0 row, last at third row, and step is 2. It means it from 0 to 3, it print the alternate row. It print the first row, it eliminate the second row, it print the third row, right? So it's about the rows. Now you need to decide which column you are going to print. So 1, 3, 9, 11 means first column this column, first column, right? So you need to put here 1 first. From all the column means 3, and you need to print the alternative column because 2 is not in our result. You need to put 1, 3, 9, 11. 1, 3, 9 and 11. So from 1 to 3 in an alternative way. Sorry, I need to 4. Sorry, 4 column, right? You can solve this with another approach as well. Let's suppose if you put here 3 and you will see if you put here 2 like colon 2, it means from start from 0 to the end and it print the alternative row, and again from 1 colon 2 it is start from first column, print the entire column in an alternative way. You will get the same result, right? You will get the same result. Okay, now fetch 4 and 7. How can you fetch 4 and 7? So first you need to think 4 is starting from row 1. So 1, 2, row 1, and the column is 0th column and the last column, means started from 0 till end and skip 2 between them, right? How it work? I want to row the first row only, the first row, this row. I will mark this row, only first row. After that, in the column section, I will start from 0th column till the end column, and step is 3. It means it eliminate the 2 column between them, right? So it print 4 and 7. Okay.
If we do not change the way we teach, 30 years later we'll be in trouble, because the way we teach, the thing we teach our kids are the things the past 200 years is knowledge based, and we cannot teach our kids to compete with machine who is smarter. We have to teach something unique, that is machine can never catch up with us. Education, it's a big challenge now.
Now I want to make it more difficult. I want to do these things in A3, and I want to change, make it more difficult so that you can understand this very carefully. Reshape this into 3, 3, 3. Okay, when you run this cell and you see the how A3 looks like. So this is a 3-dimensional array in which every element is a 2-dimensional array. If I ask you, can you fetch this 9, 10, 11, 12, 13, 14, 15, 16, 17, means the second element of the 3-dimensional array, right? Here it is the first 2-dimensional array, this is the second 2-dimensional array, and this is the third 2-dimensional array, and I am asking you to print the second 2-dimensional array. You simply do 1, you will get, if you put here 0, you will get the first 2-dimensional array, and if you get here 3 or 2, you will get the last 2-dimensional array. Okay, as the second row of the first 2-dimensional array. So this is the first 2-dimensional array, and this is the second row of the first 2-dimensional array. So you need to fetch 4, 3, 4, 5. How can you fetch A3? First you need to decide in which 2-dimensional array this value occurred, means 0. So you need to put here 0. Okay, and when you put here 0, now you need to decide which rows and column. I am asking you about only row, this row. You need to put here second row, it means the first 3, 4, 5. Okay, now fetch 10, 13, 16, where it is 10, 13, 16, this column 10, 13, 16, right, in the second two-dimensional array, the second column. So how you fetch? Simply go in that position, you will get here the second two-dimensional array. Now you need to decide which row and which column. Means you need to put here all the rows and column is first. You will give 10, 13, 16, right? I hope you get it. Slowly you will understand. The more you practice, the more you understand these things, right? So relax. Now let's suppose fetch 22, 23, 24, 22, 23, 25, 26. Where it is 22, 23, 25, 26, 23, 24, 22, 23, 25, 26. So it occurred in the last two-dimensional array. So first I need to do what? The last two-dimensional array. Here it is 22, 23, 25, 26. Now I want to ask which rows and which column. So rows started from second row till the last, and column second column till the last. So 22, 23, 25, 26. I hope you understand. Okay, now fetch 0 to 18 and 20. For your preference I want to print here. Now copy this and fetch right here. Okay, fetch 0 to 18, 20. Here it is 0, here it is 2, here it is 18, and here it is 20. Fetch. So you need to first fetch the which two-dimensional array, the first two-dimensional array and the third two-dimensional array. It means you are going to take the alternate. If you do this, you will get this first two-dimensional array and the third two-dimensional array. From this you are going to fetch 0 to 18 and 20, comma. Now you are going to decide which rows. Means the 0th rows of both the two-dimensional array. You put here 0. Now which column? So column start from 0 till the last and we eliminate the middle one. It means what? Start from 0 till the last, eliminate the middle, means the alternative. When you put this with 0 to 18, 20. If you are understanding, then it's good. If you are not understanding, you need more practice to understand this. The more you practice, the more you understand, right? Okay, thank you.
Because I feel like destiny and hard work go hand in hand. There are some things that are inexplicable that happen. I wanted to be an engineer, or at least my life. I can't speak for everyone else. And I'm an actor. That was never, no one in my entire family had ever been in show business. It was the most bizarre thing to comprehend because I come from an extremely academically inclined family. Somehow something guides you. What that is, I don't know. I don't have a name for it. I don't think it's a religion. I don't know if it's God. I don't know what it is. But I think something is bigger than us. And I believe in that.
Okay. But you don't wait for it because you're constantly working. No. And okay.
You can't wait for destiny. That's being entitled. No one can be that. You can't be like, oh, destiny's going to knock on my door one day. No, it won't. You have to be able to recognize opportunities because there'll be a lot of them that come into your life. And once you recognize an opportunity, you have to seize the day and work bloody hard because there'll be 25 other people who will want to do it.
We are going to see the iteration, how iteration works in the NumPy. We are going to see in all the dimension, 1D, after that 2D, after that 3D, right? In 1D, let's suppose if I take an example like a1 is equal to np dot arange function, and if I pass here 8. So if I print this a1, you will see it is an one-dimensional array. So when you perform iteration for I in A and want to print I, what it print? It print the each element of that array. I have also written here it print the elements inside the array. So when you are running for loop or iteration on one dimensional array, it print the element inside the array, right? Let's suppose if I take one example of this two-dimensional array, np dot arange, and we pass here like something 12, and we want to reshape this into 3,4, let's suppose, right? And if you see this array, it is an two-dimensional array where there is a 3 rows and 4 column. Let's suppose if I want to perform iteration on this two-dimensional array, what does it print? Print I. So it try to print the rows. You see here, it print this row, after that it print the second row, after that it print the third row. So I have also written here in two-dimensional array, it print all the rows, or you can call it 1D array, because one row is also known as one-dimensional array, right? So it print like this. Let's suppose if I take one, I was just example, let's suppose like something np dot arange. I will take a small three-dimensional array, let's suppose 2, and we want to reshape this into 2, 2, 2. So when you see, it looks something like this, right? I've already explained you a three-dimensional array is a combination of two-dimensional array. This is the first two-dimensional array and this is the second two-dimensional array, right? When I apply iteration in three-dimensional array, it print all the two-dimensional array, right? Here it is the first and this is the second two-dimensional array, right? So these things is working here. So we have already seen how iteration work on the NumPy array, but let's suppose if I want to find each element of a three-dimensional array, then how can we find, right? If someone asks to print the each element of three-dimensional array, then how you can do this? So for that, for I in there is a special function that is called np dot nditer. I hope it is correct. And when you pass here a3 and when you try to print the I, you will see it print the each element of the three-dimensional array, because if you see in three-dimensional array the element are 0, 1, 2, 3, 4, 5, 6, 7, it print the entire row. So for three-dimensional array as well, or for any dimensional array, if you want to print each element, you can do with this matter, right? np dot nditer, right? So I hope this is very much for right now. If I feel anything special, I will cover in the future video, right? Okay, thank you. Now in this session we are going to see the reshaping function. There are so many ways you can reshape the array, but we are going to see the important one, right? The first is reshape itself. We have already speak so many times on this, but again I want to speak. Let's suppose a1 is equal to np dot arange and it has 12 element, right? When you print a1, you will see it contain 12 element from 0 to 11. If I want to reshape this into more dimension, let's suppose a1 dot reshape into 12, so we can reshape into 3 rows and 4 column. Now we can see here we have already reshaped the given one dimensional array into 3 rows and 4 column, right? You can also reshape this into 6 rows and 2 column. You can reshape in any way, right? But in my case I will reshape like this. Okay, so I hope you understand how reshape function work. We have already speak so many times about the reshape.
Difference is we are a $3.5 trillion economy. Why is Tim Cook coming here when in 2016 he didn't? Because now India has $6 billion of revenue for iPhones. Why is Samsung, Foxconn setting up plants? Because we tried the same policies in 2016-17. And we said, if you want to sell in India, you have to make in India. Otherwise, we'll have all these high custom duties, which is what we are telling Tesla right now. They all said, okay, bye. We are not coming to India. That's what Tesla is saying, because the market for Tesla is not big enough here right now. But look at Tata, what is that, Exxon or whatever that EV is selling well. So you have to price. So the point is, once your domestic market has deepened, all these things fall into place.
So the next function we are going to see is the transpose, right? So what transpose did? So transpose tried to transpose the given array. I know it looks funny, but if you see in the mathematics, there is a concept of matrices, and in matrices we have a concept of this transpose. So what transpose do? It try to convert the rows into the column or convert the column into the rows. So here I can write so that you can understand. Here rows converted into the column and column converted into the rows, right? So you can remember, right? Now suppose A1 here is the example. A1, when you print, add and store this into A1, and now you can print A1. It contains 3 rows and 4 column. Okay, so it contains 3 rows and 4 column. When I apply transpose, so it's simply A1 dot and capital T. So it convert into 4 rows and 3 column. Here you can see A1 is it contains 3 rows and 4 column. It convert these rows into a column and these rows into the second column and the last rows into the third column. So it changed the shape. There is another way you can convert this, like mp dot, you can write here transpose and you need to pass here A1. You can also make transpose with this. The next we are going to see the ravel. What ravel do? So ravel reshape the n dimensional array into 1 dimensional. What does it mean? Means if we have a n dimensional array, suppose a 4 dimension or 5 dimension or any dimension, if I want to convert that array into a 1 dimensional array or a flattened array, we can use a ravel function. Here you can see A1 is 3 rows and 4 column. When I apply ravel on it, what does it do? It try to convert this 3 rows and 4 column matrices into a 1 dimensional array, right? So I hope you understand what reshape do, what transpose do, and what ravel do. Okay.
It is difficult to stay disengaged from the outcome. We can hope for an outcome, but we cannot plan it, and that's the biggest lesson I have learned, to be in the process so that the process itself becomes the outcome and becomes the result of what you're aspiring to do. Thank you.
Now in this session we are going to speak about the stacking. What actually stacking means? It simply means joining two or more than two arrays. We can join two arrays either horizontally or vertically, right? So in the horizontal, when we join two array horizontally, in horizontal stacking, when you join two array, the number of rows remains same, but the number of column is increased by the number of column in the other array, right? And in the vertical stacking, you will see in vertical stacking, when you join two array, the number of column remain the same, but the number of rows is increased by the number of rows in the other array. I will explain you this with the help of example, right? You can see here, you will see it is an one array, the A, and this is the another array, B, right? When we apply horizontal stacking, you will see the rows of A and rows of B are in the rows of C. Let's suppose I make this C. 0, 1, 8, 9. You will see here 0, 1, 8 and 9. It means we join both this array horizontally, right? The rows and rows are joined here as well. But in the vertical stacking, what we are doing? This is the A and this is a B, right? So we vertically join both the array. When we are doing vertical stacking and the horizontal stacking, in that situation the shape of both the array must be same, and here we join horizontally. You will observe here this is A and this 8, 9, 10, 11, this is B. So I hope you understand how vertical stacking and horizontal stacking works, right? In the horizontal stacking, you will observe the number of rows remain the same, because here in A and B the number of rows is 4, and in horizontal stacking the number of rows is remains same, 4, but the number of column is increased by the number of column in the other array. Here the number of column in A is 2 and B is 2, but in number of column in C is 4, means adding both the number of column. But in the vertical stacking, you will observe the number of column remain the same, it is 2, but the number of rows is increased by 4, means the number of rows increased by the number of rows in the B. So I hope you understand how this vertical stacking and horizontal stacking works, right?
Yeah, the thing I find most tricky is when people don't recognize you particularly, but half recognize you. You know, it's that strange thing where they go, is that? And of course that means they stare a lot, and they just look. You're sort of feeling, I wish that person wouldn't stare at me, so I'd rather just hold up a flag saying, yes, yes, it's me.
So when you see this code, like suppose if I want to take an example, A1 is equal to np dot arange 8, and we try to reshape this into 4, 2, and we also take another array and from 8 to 16, let's suppose, and we also reshape this into 4 into 2, because both the arrays must have the same shape. This is A1, you will see this is A2, right? When you are doing horizontal stacking, let's suppose np dot, you need to put here h stack. H stack represent horizontal stacking, and you have to pass here A1 and A2. I think np dot h stack. Okay, you need to pass this. If you have more than one argument, you need to pass inside an bracket. You will see here 0, 1, 8, 9, 2, 3, 10, 11, and when you match from here in horizontal stacking 0, 1, 8, 9, 2, 3 and 10, 11, right? So it works fine. But if you want to do vertical stacking, np dot b and same stack, and again you need to pass here a1 and a2. You will see the result will be the same, this result and where I explain you this result, right? So I hope you understand how vertical stacking and horizontal stacking works. It means joining two and more than two array either vertically or horizontally, right?
कि स्टे एट होम क्लोथ्स क्या है? जब आप घर पे होते हो, जब चिल कर रहे हो, आप क्या पहनना पसंद करते हो?
Very loose t-shirt and boxers.
Okay.
That's it.
Okay.
And chappal.
Now in this session we are going to see the splitting. What does splitting means? Splitting is just the reverse of stacking, right? In stacking we join the array, in splitting we separate the array, right? I can explain you this splitting with the help of example. In the splitting as well, we have a concept of vertical splitting and a horizontal splitting. Okay, if you see this picture, you will understand how horizontal splitting and vertical splitting works. First we can see horizontal splitting. So you will see this is an array given, right? A, let's suppose it is 4, 2 means 4 rows and 2 column. When you are going to do horizontal splitting, you need to draw a vertical line, right? This is the vertical line, and this is one array and this is the another array, right? So I know it's might confusing, means finding horizontal splitting you are going to draw a vertical line. It is important to remember this, right? And if you see the vertical splitting, you need to draw a horizontal line. So this, with the help of green color, I will draw a horizontal line. So this is the upper part. The upper part in the green, it is one array, and the lower part in the green is the second array. So you need to remember this. In the horizontal splitting, you are going to split the array vertically, and in the vertical splitting you are going to split the array horizontally, right? You need to remember this. Okay.
If you could change the way you wake up in the morning, stop saying, I got to go to work, I got to work out, I got to get this weight off of me. Change one word in that sentence and everything about your life changes. I get to wake up in the morning. I get to go to work. When you say I got to, you take all of your opportunities and all of your blessings and you wrap them up in stress by saying I got to.
Let's come here. Let's suppose if I take the example in the vertical splitting. Let's suppose I have A1, right? 0, 1, 2, 3, 4, 5, 6, 7, right? We have also we are getting from here, right? A1, 0, 1, 2, 3, 4, 5, 6. If I apply vertical splitting, what does it do? So you need to do np dot b split, split, right? And you need to pass here the name of the array and how many part you want. Means in this situation we want 2 part. Here is the first part and here is the second part, right? So you need to specify here how many parts you want. Let's suppose I want 2 parts. So you can see here, this is the first array and this is the second array. We can also observe here, this is the first array and this is the second array. So B split works like this. Let's suppose if I apply H split, horizontal split, H S P L I T, and you to pass here A1, and you also need to pass here the size, means how many part you want. When you run, you will see this is the first array and this is the second array. You will observe from here as well, 0246, 0246 is the first array, 1357 is the second array. Here 1357 is the second array. So I hope you understand how splitting works, how vertical splitting and horizontal splitting works. The things you need to remember is vertical splitting. If I write here, works, draw horizontal line and split the given array, and in the vertical splitting draw the vertical line and split the given array. So I will share these notes with you so that you can remember these things, right? I will share the entire this Python notebook, right? So you can understand and you can revise from here as well, right? Thank you so much. We have completed this splitting.
Some of the most successful people in the world are the ones who've had the most failures. J.K. Rowling's, who wrote Harry Potter. Her first Harry Potter book was rejected 12 times before it was finally published. Michael Jordan was cut from his high school basketball team. He lost hundreds of games and missed thousands of shots during his career. But he once said, "I have failed over and over and over again in my life, and that's why I succeed." These people succeeded because they understood that you can't let your failures define you. You have to let your failures teach you. You have to let them show you what to do differently the next time. So if you get into trouble, that doesn't mean you're a troublemaker. It means you need to try harder to act right. If you get a bad grade, that doesn't mean you're stupid. It just means you need to spend more time studying. No one's born being good at all things. You become good at things through hard work.
Now in this session we are going to see how searching works inside a NumPy array. The first is np.where, and you need to put the condition inside this, right? The function return the indexes of all the element in the array which satisfy the given condition, right? I will explain you this with the help of example, right? Let's suppose it's an array, np array, which is given. In this array, if I ask you a simple question, find the indexes of all the element in an array which are less than 5, means you need to give the indexes, all the indexes of this array where the value of the array is less than 5. So for solving this question, we need np.where, and in this condition I need to put arr and less than 5. It looks great, right? And we store this inside one variable, something like indices. We simply call np.where and pass the value of each element inside an array that is greater than 5. When you run this cell and try to print the indices, you will see a result, right? You will see the answer is 0145, means 0145 are the indexes where the value of an array is less than 5. If you see at the 0 index 0, 1, it is less than 5. 4, 5, 4, 5 means the index 4 is 3, index 5 is 1. So 3 and 1 as well less than 5, right? I have another question which asks find the indexes of all the elements inside array which are equal to 3. So you simply do np dot where and you need to pass array equal to 3. If you store this value inside an indices and you want to print the value of indices, you will see 4. Means inside this array the index 4 is equal to 3. If you see on index 4 the value is 3. So according to my question it gives the right result, right? I have asked find the index of all the element inside an array which are equal to 3. It return 4 means the index 4 is equal to 3. If you see index 0 is 2, index 1 is 4, index 2 is 6, index 3 is 5 and index 4 is 3. I hope you know the indexes part. I have explained all this concept, right? Okay, let's suppose if I want to ask you a simple question, find the index of the minimum element in an array. So finding the minimum or maximum element inside an array, we have this np.argmin or np.argmax. If I want to find the minimum element, we simply do np.argmin and we need to pass the array. So it return 5 means 5 is the index of the minimum element. If you see here the index 5 is 1 and in this array 1 is the minimum element. So I hope you understand how it's work. Let's suppose the next question is find the indexes of the maximum element in an array. For that you need to simply do argmax and pass that array. If you see it is 6 means 6 is the index of the maximum value inside an array, and if you see here 6 the value is 8 and 8 is the maximum value inside this array. So I hope you understand how this searching works. The first is np.where where we need to put the condition and according to the condition it fetch the indexes, and the second is argmin and argmax which give you the minimum and maximum value from the array. Okay, thank you.
I spent $1 million in 30 minutes. I get a check for $1 million from a trading car company. Always wanted a black on black Mercedes Benz. So I go get it, boom, 150,000. So in my mind, 150 minus $1 million, I still got 850 left. I'm still good. So I get home. My father said, "That's nice. Where's mine at?" I was like, you know what? You're right. So if it wasn't for you, I wouldn't be here right now. Me and him, we get in the car, go get the exact same car for him. We get home, my mom's a little jealous. Where's mine at? So we go, and we get her the smaller Benz version. So we got 3 Benzes, and I get a call the next day from the bank manager, and he says, need to have a conversation with you. So I come up there, and he says, Shaq, you know, athletes, when they're done playing, it's a large percentage that have nothing. So I've been following your career, you're bright, young star. I don't want you to be like that. You need to learn how to take care and manage your money. You know, General Eisenhower said the greatest leaders are the ones smart enough to have people smarter than them around them. There are a lot of smart people around me.
Okay, now in this session we are going to see how sorting works inside an NumPy array. The first way is np.sort and we need to pass the array, right? And the second is array.sort, and the last is np.argsort. We are going to see all this with the help of simple example. np.sort and we pass the array means the function return a sorted copy of the array, means it do not modify the original array. Let's suppose if I explain you this with the help of example. If I copy this array here, and if I sorted array, and if I pass np dot sort and to pass here the name of the array, right? And when you print this sorted array, you will see the value is sorted in ascending order, right? But it do not modify the original array. If you see the original array, print arr, you will see it is as it is, right? Is it as it is, like the earlier. Now we see the second method, that is array.sort. If I copy the same array and if I work on it so that you can understand very well. If I apply array.sort and if I pass this, you will see when I print this arr, it modify the original array. Here the value of arr is changed, means the value of arr is now the sorted array. So np.sort, it do not modify the original array, but array.sort, it modifies the original array, right? I hope you understand what is the difference between the np.sort and array.sort. The last is np.argsort. What argsort do? Again, we need to copy this array, and I want to explain with the same example. If I apply sorted indices, you will see np.argsort, and you need to pass the array, and when you print the sorted indices, you will see 160924875. What is this? It returns the index of the sorted array. If you see here 1, it means at index 1 the minimum value of the array. Here the index 1 is the value 1, means inside this array 1 is the minimum value. After that the value is 2. Here you will see index 6. If you count here, 2 is at index 6. After that the minimum value is 3, that is index 0. If you see here, it is given index 0. After that again 3, that is index 9, and after that 4, here is the 4, and if you count the index is 2, right? So in this fashion it try to sort the indexes, right? I hope you understand.